In this video, we're going to take a look at simplifying algebraic expressions, so getting an understanding of what are like terms and what are unlike terms, and then the process of combining like terms, and then looking at writing phrases from as an algebraic expression and simplifying, so still combining like terms. So first we want to understand what is a like term. So like terms are when we have the same coefficient, same variable with the same exponent. So for example, like x to the first, 2x to the first, and 3x to the first are the like terms because they have the same variable, x and x, with the same exponent, 1 and 1, x to the first. Or 2x squared and 3x squared. You could have multiple variables as long as those variables have the same exponent. So an example of that, 2xy and 3xy. X to the first, y to the first, x to the first, y to the first. Same variables, same exponents, so those would be like terms. So on the couple examples I have here, so number 1, 8x and 8x squared. X to the first, x to the second. Those are not the same exponents. Even though they're the same variables, they are not like terms, because they are not the same exponent. It has to be x to the first, x to the first, or x to the second, x to the second. But in this case, they're not. So number 2, 2xy squared, 10x to the first, y to the second. So we have x to the first, x to the first, check. Y to the second, y to the second, check, check. So that means that these are like terms. Good to go. Number 3, negative 4, x to the first, y to the first, z to the first. Negative 6, z to the first, x to the first, y to the first. So a couple things. First, same variables, x, y, z. Second, all the same exponents. Third, they're a different order, but that's okay. That's okay, because if you think of the commutative property of multiplication, you could rearrange terms. You could rearrange x, y, z to be z, x, y. So the order of the terms, I'm sorry, not the terms, the wrong language there. The order of the variables doesn't matter as long as it's multiplication, because the commutative property of multiplication allows you to rearrange. So in this case, yes, these would be like terms because they have the same variables, x, y, z, z, x, y, same thing, and then they all have the same exponent. Even if if you just threw in a 2 on that one. So we have x, y, z, zx squared y, they are no longer like terms because of that single one variable being x to the second throws everything off. Number 4, 2x squared y, and negative 3xy squared. So in this case, x to the second, x to the first, not even like terms. I'm not even going to look at the y because I have x squared and x to the first, so they are not like terms. And number 5, we have the constant 2 and 2x. So 2 is just a term without a variable, and then 2x is a term with x being the variable. Those aren't the same. They have to be the same variable, or both constants, like 2 and 3 would be like terms, because they don't have a variable. So those would be like terms. But in this case, we have 2 and 2x, so those would be not like terms, unlike. Very good skill to make sure you know how to combine like terms, or identify like terms. So simplify by combining like terms if there are any like terms. So number 6, 11x minus 3x. 11x and 3x are like terms because they're both x to the first. So when we're combining like terms, we just perform the operation. It's just going to be 11 minus 3. You just perform the operation with the coefficient. So 11 minus 3 is 8, so I get 8x. Number 7, 10y squared plus y squared. The coefficient on the y squared is 1, so that's going to be 10 plus 1. Just doing 10 plus 1. So 10 plus 1 is 11y to the second. So the variables you just leave as a term. Like the variable identifies terms, and we don't do anything with the exponents. I don't do 2 plus 2 or anything like that. The variable and the exponent just indicate like this is a term. This is the y squared term. So number 8, 10y, 12y squared minus 13y. We have 10y minus 13y. Those are like terms because they're both y to the first and y to the first. The 12y squared, we don't have any like terms with that because it's y to the second power. So that's not a like term. So I just have to do 10 minus 13, so 10y minus 13y plus 12y squared. 10 minus 13 is negative 3y. 10 minus 13 is negative 3. And then we have the plus 12y squared, and these are not like terms again because they are not the same exponent of y. It's just y to the first and y to the second, so those would not be like terms. Number 9, 11z to the third minus 1z to the third plus 3z to the third. So these are all like terms, z to the third, z to the third, z to the third. So those are all like terms. We need to combine all three of those terms together. So we're just going to add or subtract the coefficients together. So you're going to do 11 minus 1 plus 3 because they're all like terms. So whatever we get, it's just going to be the term z to the third. So 11 minus 1 is 10. 10 plus 3 is 13. So the answer being 13z to the third. Number 10, 8xy minus 10 plus 15yx minus 11. So you got to be careful with a couple things here. First of all, we have this term xy, and we have this term yx. Are these like terms? Yes, they are. X to the first, y to the first, y to the first, x to the first, same variables, same exponents. So they are like terms. So we're going to combine those together. So you're going to do 8 plus 15. In addition to that, you have like terms with the constants. Negative 10 minus 11. Those are like terms because they're without variables. So I'm going to do 8 plus 15. 8 plus 15 is 23, and I just wrote 12 for some reason. 23 xy or yx, it doesn't matter. And then negative 10 minus 11, those are like terms. So we're going to do negative 10 minus 11, which is negative 21. So 23 xy minus 21. Then number 11, we have distributive property here because we have 3 times all of this. So I'm going to do 3 times 3x, 3 times negative 4y, 3 times 5. I'm distributing the 3 into the entire parentheses there. So 3 times 3x is 9x. 3 times negative 4 is negative 12y. 3 times 5 is 15. So those, after we multiply all that out, do we have like terms? You go through all the terms. We have an x, we have a y, we have a term without a variable. So we don't have any like terms at all. X and y are not like terms. The term without the variable doesn't have another term without a variable. So we have nothing to combine. So it's not like we had any like terms to combine in this example. This was just an example of distributive property, but sometimes we will generate some like terms after distributing. But in this case, we don't. We don't have any like terms at all. So number 12, we want to distribute the negative 7. So negative 7 times negative 2x, negative 7 times 6y. And then we also have this plus x minus y. Now we are not going to distribute all the way to the x and the minus y. It's only negative 7 times this. So we are not distributing all the way to that x minus y. So negative 7 times negative 2x is positive 14x. Negative 7 times negative 2. Negative times a negative makes a positive. Negative 7 times positive 6 is negative 42y plus x minus y. Now we have like terms because I performed the distributive property and I still have that plus x minus y. So now I do have some like terms that need to be combined. 14 minus 1, or I'm sorry, not minus, 14 plus 1 is 15x because this is a 1x. And then we do have the like term of negative 42y minus 1y. So negative 42 minus 1 is negative 43y. And 13, we have distributive property twice. Careful, you might miss this. 4 times x, 4 times 6. And then we have, we want to subtract off all of 5x minus 7. So I want to do negative 1 times 5x, negative 1 times negative 7, because I want to subtract off all of that statement. So I want to take the opposite of 5x, I want to take the opposite of negative 7. So 4 times x is 4x, 4 times 6 is 24, minus 5x plus 7. I'm taking the opposite of 5x and negative 7 because I want to subtract off all of that. And then once we subtract that off, we have some like terms. So 4x minus 5x, that's a like term. And then we also have 24 plus 7. Those are like terms. So 4x minus 5x, 4 minus 5 is negative 1x. 24 plus 7 is 31. Last two examples of combining like terms that I have, and then we'll look at the statements. We have negative 13x minus 14 plus y, and then we have some extra terms after that. So here, same thing I said on 13 with negative 1 times 5x, negative 1 times negative 7. We want to do negative times 13x, negative times negative 14, negative times positive 1y. So you're essentially just taking the opposites, or you can think of it as negative 1 times 13, negative 1 times negative 14, negative 1 times y, and then we'd go from there. So let's just do that. So negative 1 times 13 is just taking the opposite, so negative 13x. Negative 1 times negative 14, taking the opposite, so it becomes positive 14. Negative 1 times y is negative 1y minus 8x plus y. A couple like terms that we can combine here. I'm seeing negative 13x minus 8x. Those are like terms. I am also seeing negative 1y plus 1y. Those are like terms. And then I do have this like lonesome plus 14. I don't have any other terms with just constants, so I can't combine that with anything. But I'm going to do a little bit here. So negative 13x minus 8x is negative 21x. Negative y plus 1y. Negative y plus 1y. That's going to be 0. Negative 1 plus 1 is 0. So here's the common mistake here. That's just 0, not this, not y. If you write y, you're indicating that the coefficient is 1. That's not the coefficient. The coefficient is 0. Negative 1 plus 1 is 0. So you have 0y, 0 times y is 0. So you don't have a y anymore. You have 0 y's. So you are not going to write y for that negative 1y plus y, but you are going to write plus 14 because you still have that plus 14 there. Okay, number 16. Pretty similar to 13. We want to just take the opposite of each term. So 18x minus 7x minus 11. 18x minus 7x. 18 minus 7 is 11x minus 11. And then those are not like terms, so you leave it as 11x minus 11. A lot of good examples there. A lot of good examples. Now we're just going to do some examples of writing the phrase as an algebraic expression and then simplifying if possible. This is a really difficult skill for a lot of people. This is something that takes a lot of practice, even when if you're somebody who's traveling through all of the maths, like you're going through intermediate algebra, you're going through elementary algebra, intermediate algebra, college algebra, you're going through that whole track. This is something that you keep on practicing. So we want to subtract 9x minus 17 from 4x plus 13. So what does that mean? If we want to take something away from some total, just like if I said, I have $10, or you have $10, and I want to take away $5, what would you do? You'd say, well, I have $10, and you want to take away $5. 10 minus 5 is 5. You take away, you'd subtract off that 5. So if I want to subtract 9x minus 17 from this total, I want to take away 9x minus 17. So I want to have 4x plus 13 minus, in parentheses, 9x minus 17. See how I put that in parentheses? Because I want to subtract off this entire amount. I don't want to just write it like this. I don't want to write 4x plus 13 minus 9x minus 17. Because what you're saying there is you're just taking away 9x. And then you still have that minus 17 there. But we're not taking that away. Like we want to subtract off all of that. So really, this becomes minus 9x plus 17. So I'm just going to use this little line that I wrote down. So this is going to be minus 9x plus 17, because I want to make sure I'm taking the opposite of that entire parentheses, because I'm subtracting off all of it. And then, with that, we have some like terms. 4x minus 9x is negative 5x. 4 minus 9 is negative 5. Then we have 13 plus 17. Those are like terms. That's going to be 30. So negative 5x plus 30. Double a number plus 5. So doubling some number and then adding 5. Well, we don't know the number. So that's going to be x. We want to double it. How do you double something? If I have $10 and I want to double $10, I now have 20. What did I do? I multiplied by 2. So doubling a number, 2x plus 5. Plus means addition. And then 5, just 2x plus 5. Nothing to simplify there. 7 added to triple the sum of a number and 3. This is interesting. 7 added to triple the sum of a number and 3. So we're taking 7, we're adding it to something happening. We're adding this to the triple of the sum of a number and 3. So I am tripling, multiplying by 3, the sum is addition, of some number and 3. So 3 times x plus 3. So 7 added to triple the sum of x plus 3. So whatever the sum of the number of x plus 3, think of it this way. Whatever this sum is, I'm going to triple it. Right? If my sum between some number and 3 is 5, I'm going to triple that by multiplying it by 3. I'm going to take triple that, so 5 times 3. What if the sum is 10? 10 times 3. How do I triple that? I just multiply by 3. So I have to put parentheses around that because I want to triple whatever this sum comes out to be. That's a really difficult one to translate. That's a difficult one. So now we're going to distribute 3. So 7 plus 3 times x is 3x. 3 times 3 is 9. And then we do have some like terms right here. 7 plus 9 is 16. So 3x plus 16. Really you want to just, focus a lot of your energy in here. Just making sure we know how to get that set up. Because if you know how to simplify, then that shouldn't be the issue. The setup is where we really want to focus in on. And last one for this video. The sum of twice a number, 4 times a number, and 3 times a number. So the sum of 2 times a number, 4 times a number, 3 times a number. So 2 times a number is 2x. 4 times a number, 4x. 3 times a number, 3x. And I want to take the sum of all of those things added together. So I'm just going to slip addition signs in here. So it's 2x plus 4x plus 3x. I think I'm getting a little close to my camera. 2 plus 4 plus 3. These are all like terms because they're x to the first. So 2 plus 4 is 6. 6 plus 3 is 9. So 9x. So this is a fun one. This is the sum of all of these things added together. Don't get frustrated if something like this, these last couple problems, are a little bit difficult, like this one especially. This is a tough one. This is a tough one. Like this is a really difficult skill that you just got to keep practicing, keep getting better at.